There are basically three strategies when you want to lie. The first is just forget to say the truth. The second is to give a false statement. And the third is to make statistics. Not sure this joke was really fun, but for sure there is something true there. If you want to lie, you can definitely use statistics to make up whatever statement you want. But actually, I don't really want to speak about this in this video. I rather want to point out that making statistics is really a challenging task. And the reason is that you cannot just memorize definition, apply formulas, and get your results, because in this way, almost for sure you're gonna make a mistake. I decided to make this video after a recent somehow discussion I had, and I tried looking into Google what's going on. So, I search no correlation. What does it mean? And the first result you get, actually, if you look at it, is that basically when you have zero correlation means there is no correlation between two variables. I don't really agree with this statement, but it's the first one you get, and that's making me thinking many people believe in this. So let me start with an example. You're a farmer, you're working your field, and one day you go and you see something like this. So the grass, the vegetables are somehow damaged, according to this shape you see in this photo. So of course you might wonder, is this something random? I mean, there was some strange storm that randomly destroyed the grass and this is the result? Or is it something planned by whatever we can call smart creature? Now, before continuing the discussion with the statistics, I would like to open a parenthesis of a personal opinion. If you go to a field and you damage in this way, you are not fun. The farmer worked hard, they spend money to work the field, to buy the machinery, to pay tax, to put the seeds. They take care for a long time, and then when it's time to collect the result of their work, you spoil it in this way. That's not smart. Well, anyway, let's go back to statistics. We can analyze this using mathematical tools and analytics to provide a quantitative answer. The first step is to draw some points, so we can later on define a coordinate system and measure the position of these points, and for each point, of course, we can assign, coordinates with some distances, matrix, whatever. So then we can put all the results of our measures in a table, and by fancy analysis like this, you can ask even Excel to do it, and you can make a linear regression of these points. So according to what we said, if the correlation is zero, there is no relation between the two variables, and if there is no relation between the two variables, there is no smart creature creating this. So if we look at the numbers, okay, maybe you are not familiar with the IT stuff, so E minus 33 is computer way of telling you zero. Computer, they speak in their own language, but I'm translating for you. So basically, here the results we get of the correlation is zero. And so we have the mathematical evidence that no smart life form created this damage in the field. Yeah, somehow I agree with this statement, but of course you might complain and say, come on, something is going wrong. The damage in the field is definitely not random. There is many circles. Come on, of course something is there. So the problem, or if you like, the explanation of what's going on is very simple. There is no linear correlation between the points. We used a linear regression. So the statement is the points are not sitting on a line. This is the statement we are making. Yes, they don't sit on a line. There are many circles, of course. But we have to be careful, because I spoke with many people and talk around. Many people mistake this. When you make a linear regression, you get zero correlation, you are proving that the points don't sit on a line. You don't prove anything more. And you have to be really careful because this generates many mistakes. We should be really precise in the statement we make. We are talking mathematics. We are not talking, unprecise language. Now I want to give you another example that is a bit more tricky. So let's consider the case where we have several pairs of numbers and they look like random. Now, to study them, one of the simplest and most used strategy is just to use these pairs of numbers as xy coordinates of points, so we can plot them and we can compute correlation. And of course, you are provide a couple of examples. Left, we have 0.17, so basically zero, no correlation. The left one as well is basically no correlation. And if you stop your analysis at this point, you think, okay, I did my job, everything is fine. But now let's use another methodology to analyze the data. Instead of using the pairs of points like x and y coordinates, we can use the first point of each pair and we represent in violet, and the second point we represent in orange. So basically what I'm doing is that the x coordinates and the y coordinates are separated by color, not by position. So in the below plot you see the same info, but using a different plotting strategy. Why am I using this? Now, representing with the same strategy the set of data that was on the top right plot, you can see that the y and the orange point, they basically overlap. So something went wrong, I would say, because there is a very, very strong correlation between them. Now, to solve this, the easiest, in this case, is to look at the numbers itself, the raw data. So I report here at the table with all the data, and if you observe carefully, the left set of data is kind of random numbers. The right set of data, you have just shifted the column. So basically you can completely predict the numbers in the y column, I call it y, by just taking the x column and shift it by one position. You can also see that in the top right plot, every time you find a point with a certain coordinates in x, you find another point with exactly the same coordinates in y. It's kind of a complex mirroring on the diagonal of this plot. Now, after this, I would like somehow to summarize the point I want to make through this video. When you study statistics at school or high school or university, generally you don't have much time and your professor is running, literally running to teach you everything. So they start with, definition of average, median, percentiles, regressions, whatever, distribution, chi-square test. And given limited amount of time, of course, they go fast to each topic, and then you memorize them all, and then you go to the exam. So at the exam, they give you some number, and maybe they ask you to make a linear regression. You start, with your calculator, you put all the number, and you're sweating like crazy, and to get the result. Okay, but I think by this race, you miss the point. The point is not to compute the average. The point is to understand the average. The point is to make sure you understand what you are doing, what the data are telling you. And it's always very tricky to understand. This part is really complex. So in my opinion, the work of the statistician is very similar to another job. Let me show you. I really think there is an analogous situation when you study forensic science. When there is, for example, a murder, the police goes there and, they start making many tests and searches for, fingerprints, DNA, saliva, maybe some blood, and then they search for, maybe there is a camera with some recording, or there are people that saw something, and, they look for fingerprints and whatever. Okay. Now, let's say you are the detective. The fact you go to certain crime scene and you find my fingerprints does not imply I am the killer. It implies that I was there. Or if you go there and you don't find my fingerprints, does not imply I'm innocent. Maybe I was wearing gloves during the murder. So, all of these tests that the police is doing, they are kind of components of a puzzle. But the job of the detective is to put together over all of these components and solve and find the full picture. That's really the challenging job. It's not to make the analysis, it's to put together the entire picture. And in statistics, it's exactly the same. You collect many info when you have a bunch of data, you make your own analysis, but then you have to look at the full picture and try to get what's going on there. Statistics is not about computing an average or a linear regression. For this, you can just use Excel. I mean, as simple as that. Those are tools you need to do your job. And too many people, they don't understand, at least in my opinion, this point. At the university, the teachers somehow fail, not because they are not good, but because they have too many topics to teach. Always remember, when you look at data, there is some info hidden there. You use many tools to extract the final info. His job is to understand what's going on. If you do a good job, you are a good statistician. Of course, if you are, let's say, naive, or you are dishonest, and then ended up that the first result is here highlighted in yellow. So recently I was doing I decided to make the... Anyway, let's continue. Question. Anyway, let's continue. So the question is, are those random or is it something planned? But anyway, let's go back to statistics. We can analyze this data. We can analyze this using mathematics and find an analytic. We can analyze this using mathematical tools and analytics to provide a quantitative answer. The first step is to draw some red points, let's say red. The first step is to draw some points. We are mathematically sure nobody smart do this. And so we have the mathematical evidence that no smart creatures, no smart life form did this. Okay, for sure that no smart life form created this.